In this particular diagram, I've got a rectangle and some points. So first, let's find the length of CF. CF is simply 2 cm. Where is Ruben? What happened to it? Why? Switch. Okay, so FC is simply 2 cm. Because the length of the rectangle is just 8 minus 6, you get 2. Simple. Now the area of AECF. AECF, basically the shaded area. We see there is a trapezium. Okay, because you got parallel sides on opposite ends. So the area is simply half times the sum of the parallel sides, 3 plus 2. We found that it was 2 early on, times the perpendicular height. Because this is a rectangle, its perpendicular height has a distance of 5, length of 5 cm. So 5 times 5, 25 divided by 2, 12.5 cm square. Okay, 12.5 square centimeters. Even though you are unable to draw perpendicular distance from F down to the base, because the base is just AE, right? No matter which point you choose, you cannot reach the base of AE, but doesn't matter, just like your triangles, you can easily extend it and we still have the same perpendicular height. So next, shaded area is a percentage of the area of ABCD. Once you are able to get the area of AECF, you should have no problem. But I want to remind you for your presentation, shaded area, percentage area will be 12.5 out of the total area, which is 8 times 5 times 100%. I need you to check your work that you have a percent symbol over here. Don't have percent. Oh, you didn't write the annotation over here, is it? That means you're just giving me working without explanation. Minus mark. Okay, so let's carry on. From here, you will have an exact answer, 31.25%. Okay, so the things I'm taking note of will be those that are highlighted as well. So that's question 5. Question 6. Similarly, we are given one side of this quadrilateral, but this time they say that M is the midpoint. So it is right smack in the center, which means that we have 9 cm and 9 cm for each of them. Why 9? Well, 18 divided by 2, that's 9. So part A is done. Ratio of the area ANMD to NBCM. Ratio of area. So you might be thinking, hey, I don't even know the height. How am I going to find the area of the height? Right, we know that the area of a trapezium must be half times the sum of parallel sides times the perpendicular height. But we don't have that. Question didn't say. Then how to find the ratio of area if you don't have, if it is impossible for you to find an area? Take what? Okay, so we need to write down for part B, let H be common perpendicular height. H has to be the common perpendicular height because these two trapeziums, they do share the same perpendicular height. It's quite common. It's the same. And now we can write down the ratio. Area of ANMD to NBCM. You can do it in this ratio presentation or you can do it as a fraction. I will demonstrate ratio first. Okay, so ANMD, the trapezium on the left hand side, area will be half times the sum of the parallel sides, 6 plus 9. 6 plus 9 times H. Whereas the trapezium on the right hand side, half sum of the parallel sides, 12 plus 9 times H. You can try and evaluate 12 times 15. times h. So that gives you half times 15 times h. So that's 7.5 h. Yeah, you can do that. But how about we just divide both sides? Divide by half. Okay, if we do it step by step, we divide by half first. We end up with 15h to 21h. And I think you can divide by h by yourself, you get 15 to 21. Of course, you have to divide by 3. So you get 5 to 7. So this is how you do it by ratio. The alternative presentation, ANMD and BCM. So by writing it as a fraction, half times the sum of the parallel sides, 9 plus 6 times h over half 12 plus 9 h again. So doing this will result in the same answer. But here we can see clearly that we're just going to cancel away all these things, leaving us with 15 over 21, which is our 5 over 7. So since ANMD to NBCM is 5 over 7, our final answer ANMD to NBCM 5 to 7. Okay, we don't need to find the height. And now they are telling us, oh, area of ABCD, the entire quadrilateral has area of 200. Joban. Entire area is 200 square centimeters. Find the area of ANMD, just the smaller one. Okay, so a few ways you can do it again, but since we already found the ratio of the areas, we're going to use that. In total, we have 12 units. 5 plus 7. Japan, focus. 5 plus 7, we have 12 units. 12 units representing 200. Represent 200 square centimeters. We only want the trapezium on the left, and we said that it was 5 units. Represents 200 over 12 times 5. Because they are directly proportional, so divide, multiply, and get the answer. 83 1/3 square centimeters. Now for question 7, and this is the last question I'm going through. I know that there is one, I think question 9, but that one's quite simple. Finding perimeter and area only. We're more concerned about this kind where you have unknown heights. Then you see how you deal with them. Okay, so question 7. Trapezium again. Now they tell us area of triangle ACD. ACD 75. 75 square centimeters. We've got a distance over here as 10. I think they are going to be using perpendicular height. So include your perpendicular height over here. And notice that this perpendicular height that I just drew will be the perpendicular height for the other triangle. It is where 18 is the base. And again, it will be the perpendicular height for the entire trapezium. So these are the things that you must be thinking of. Find the area of A, B, C, D. So first, we want to find out the value of H. So area of triangle, let perpendicular height be H. So half times the base of 10 times the height is 75. So this is from the area of the triangle that is given to us. So H must have a value of 75 divided by 5, 15 centimeters. So we know that this is equal to 15 already. So area of ABCD, sum of parallel sides times 15. You get the answer 210. Of course, with this 15, you can calculate the area of the other triangle. Then just add, it's the same. Okay, any questions for this work? Quite straightforward, huh? These are the new skills that you must have. Okay, next one. Our chapter 12, part 4, the remaining set of the notes. So this was our first homework question from the notes. 10 square meters to square centimeters. So you write down 10 square meters. Copy down the same number. From meter to cm, we will need to multiply. Meter to cm, we need to multiply by 100. But because we're dealing with areas, we have to square it as well. That gives us a very big number. Okay, check our work. Next, part B, 25000, 25,000 square centimeters. Yes? The entire set of notes. So copy down the number 25,000. From cm to meter, we will need to divide by 100. Put on the division by 100. And because we're dealing with area, square it. Square only that 100. So instead of using a calculator, you can also practice your handwritten work. So the decimal point over here, 1, 2, 3, 4. Because you're dividing by 10,000, giving us 2.5 square meters. Okay, I'm just going to go through the rest quickly. So move the decimal. 1, 2, 3, 4. 3600 square centimeters. Next one. Copy down the number. Because we're going from cm to meters, we're going to divide. We should divide by 100 and then square it again. So move it 4 times. 1, 2, 3, 4. 0.058. Definitely will be testing. Next. Okay, practice 5. Got an icon for a camera. Find the perimeter of the shaded region. Trace out the perimeter that they are talking about. Horizontal, diagonal, horizontal, diagonal, horizontal, vertical, horizontal, vertical. Did I trace out the perimeter already? Did I? No, I haven't. There's also the circle. Okay, so perimeter will include all these portions. Now, we are interested in the presentation. So do we actually have all the distances already? Yeah, actually they're all given already. This one over here is 4. So just add everything up, you should not have a problem. Okay, and the answer is given to you. You can check. Part B, find the area of the shaded region. So what is the plan? The plan is to find the entire area minus away the area of the circle. That's it. So this diagram can be divided into a trapezium. The plan is to divide it into a trapezium and a rectangle. Find total area minus area of the circle. So area of the trapezium can be done also. We need the length of the base. And that is given by 6 minus 3, which is also 3. So with that, you can also find the area of this trapezium. Then rectangle is not a problem. Minus the area of circle is also not a problem. So just a recap. Area of circle is pi r squared. Perimeter or circumference of circle is pi d, which is the same as 2 pi r. I think this wasn't tested for PSLE, right? Was it tested for PSLE? I thought it was our last topic and then they removed it. Huh? Speed, they didn't test speed. Okay, so I want you to take note of the square over here for the area of a circle, because it is a common issue that you mix them up, they do not know which is for which. So the square over here must be for area, just like your square centimeters, your square meter, so on and so forth. The one that doesn't have a square has the units of centimeters, meters, millimeters, so on and so forth. So that will be length. Okay, 6 we've done already. Question 7, and then finally 8. So question 7. This was also a homework question. Actually, nothing complicated. So just add everything up. You have all the distances already, except for AE and HD. But do you actually need to know the distances for AE and HD separately? We don't lah. We're going to add them up anyway. So what we're going to do is to take the distance of 40 minus 30, which is 10. It tells us that AE plus HD is equals to 10. And then from there, you can continue using the information already. So again, this is pretty straightforward. I'm not going to go through. You've got the answer over here already. If you didn't manage to reach the answer, it is most likely a careless mistake. And for part B, square centimeters for cross-sectional area. Cross-sectional area, this is made out of 2 trapeziums. A big trapezium. You've got a vertical height, you've got a length on the parallel sides. And you're going to take away the area of the smaller trapezium. That's it. So again, not going to go through. Practice 7. And the last one. Find the area of the shaded region. Think of your plan. How do we obtain the area of the shaded region? Well, this is a rectangle with a cutout. What did we cut out? We cut out 2 triangles. We can easily find area of triangle if we have the base and the perpendicular height, which is given to us. Square root 2 and square root 2. Okay, then what is left will be the area of this part of the circle. So this part of the circle is known as a sector. And that is what we will need to find out. Okay. So how do we determine the area of this shaded region? I mean this sector. Any good suggestions? What proportion of the circle is this? Quarter? How do you know it's a quarter? How do you know it's a quarter? That's not a good enough reason. Yes, William? How do you know it's a right angle? Did they say it's a right angle? No, they didn't say it's a right angle. So okay, Jovan, hold on first. Anybody else? Anybody else able to tell what this angle is? Over here. Because I'm hearing you guys saying that it is 90, but the question is, how do you know it's 90? How do you know it's 90? Yanjing, how do you know? For the triangle, let's talk about one of these triangles. Okay, what do you want to say? The other 2 sides add up to 90. So she is saying that one angle here plus the other angle over here, they add up to 90. Okay, yes, because angle sum of triangle is 180, right? And we've already got a right angle triangle. So the other 2 must add up to 90. Okay, so what? Wait, how do you know that one of these angles is 45? That's the key, right? How do you know it's 45? Above square root 2. Notice the two sides have the same distance, the same length, right? Hey, if the triangles has two of same side, what kind of special name do we give this triangle? Isosceles. So what is one other property of isosceles triangle? Base angles are the same, right? So if they are the same and they add up to be 90, therefore each of them must be 45. So this is correct. This is 45. Similarly, this is also 45. And we have got angles on a straight line, adjacent angles on a straight line, they must add up to 180. So in short, 180 minus 45 gives us 90 degrees over here. That is how we determine that it is 90. Not by, it looks like 90, so I'm going to think that it's 90. No, it doesn't work that way. So now we have proven that it is 90. With that, it is confirmed that it is 1/4 of a circle. And 1/4 of a circle, we can find out the area easily. Area of quarter is 1/4 times pi r squared, where the radius is 2. So you can find quarter, you can find triangle, find rectangle, subtract, done. That is the plan. And then finding the perimeter is even easier. Okay, the arc length. We need to find this arc length, which is 1/4 of the circumference. That's all. Okay, so